So don't forget, you can only add or subtract them if they have the same radical. Luckily, you can multiply anything with anything. So here we have to distribute this root 3 to both of them. Not terribly complicated. It's just something new to get used to. Root 3 times root 6. That's root 18. Plus, when I do root 3 times 7, remember, we're not going to make it root 21 because that 7's not in a radical. 7 times the square root of 3 is just 7 root 3. You just mash them. 7 root 3. Or you can think of root 3 as 1 root 3. 1 root 3 times 7 is 7 root 3. These do not have the same radical, so we can't combine them. However, there's still a perfect square in 18. It's 9 times 2. The square root of 9 is 3. 3 root 2 plus 7 root 3. There are no more perfect squares. We cannot combine them. So that's it, man. That's it. I have 3 here. I'd like you to pause it and try at least 2 of them and check in with when you're done, and let's kind of see if we got the same thing going. All right, root 5 times 2 is 2 root 5. Plus root 5 times root 10 is root 50. 50 I know is 25 times 2, which is 5 root 2. 2 root 5 plus 5 root 2, you can't combine them because they have different numbers in the radical. All right, root 2x times root 6x would be root 12x squared. Minus root 2x times 11 is 11 root 2x. I know 12x squared has a perfect square of 4x squared in it. It's 4x squared times 3. The square root of 4x squared is 2x root 3. 11 root 2x has no perfect squares, so we just leave it. And this is it. Root 5a times root 5a. If we remember our square root of smiley face times the square root of smiley face is smiley face. The square root of 5a times the square root of 5a will just be 5a. And then the square root of 5a times 3 is 3 root 5a. No more perfect squares than that, so it's all done. All right, we distributed. Now we're going to FOIL it. Ooh! First, outer, inner, last. All right. It's basically 2 problems in one, that's all. So we're doing root 5 times root 5. Square root of 5 times the square root of 5. Square root of smiley face times the square root of smiley face is smiley face. Square root of 5 times the square root of 5 is just 5. Then we'll do our outermost. Root 5 times root 15. 5 times 15 is 75. So root 75. Now we're doing negative 2 root 15 times root 5. Well, all we're going to be able to multiply is the radical with radical, so it would be negative 2 root 75. And then the last, we have negative 2 root 15 times root 15. Negative 2 root 225. All right. You could break down the perfect squares here, which is what I'd recommend. There's nothing to do with the 5, but 75 is 25 times 3. And then 225 is a perfect square. It's just 15. So let's clean up some stuff here. We have the 5 plus this root 25 is 5, so 5 root 3. Here, the square root of 25 is 5. 2 times 5 root 3 is 10 root 3. And over here, minus 2 times 15 is 30. Now, what could we combine out of this stuff? Well, I could just do 5 minus 30. That's just normal numbers. Negative 25. And then these are both root 3's. So we have 5 root 3 plus 10 root 3. It's 15 root 3. So a lot of breaking down, a lot of multiplying. Combine your like terms, but it's okay. You got this. You get better at it by trying it. So why don't you try one of these two? Now the second one says squared. I think it's helpful to write it like we were doing when we had binomials before. Just write it twice. Root 7 plus 4 times root 7 plus 4. Highly recommend it. All right. 2 root 6 times 1 root 6 would be 2 root 36. 2 root 6 times negative 5 root 3, well, 2 times negative 5 is negative 10. 6 times 3 is 18. All right. 3 root 3 times 1 root 6 would be 3 root 18. And 3 root 3 times negative 5 root 3 would be negative 15 root 9. Now, I notice these are both root 18s. We can combine them now. I also know that 9 is a perfect square that goes into it, so you could break it down first with that as well if you want. Here, look, 2 root 36 is really 2 times 6, which is 12. Let's break down the 18s. 9 times 2. Square root of 9 is 3. So 10 times 3 root 2 would be 30 root 2. If we're working on this 18 here, it's 9 times 2. 3 times 3 root 2, which is 9 root 2. And then back here, 15 root 9. Square root of 9 is 3, so 15 times 3 is 45, so minus 45. All right, so I could do 12 minus 45. It would be negative 33. And then these are both root 2. Negative 30 root 2 plus 9 root 2 is negative 21 root 2. All right, over here. Square root of 7 times the square root of 7 is just 7. Square root of 7 times 4 is 4 root 7. 4 times the square root of 7 is 4 root 7. And 4 times 4 is 16. I could do the 7 plus 16, that's 23. I could also combine 4 root 7 plus 4 root 7 is 8 root 7, and that's all we can do. I'd like to show you one more thing. Remember, you are not allowed to have radicals in the denominator. We have to clear them. Now this has subtraction with the radicals in the denominator. So we're going to use what's called a conjugate to cancel that out. And it's rooted in, if you remember the old difference of squares back in the day, when you had something like x plus 5 times x minus 5, they're the same thing except one has a plus, one has a minus. If you were to FOIL these out, we'd get x squared minus 5x plus 5x minus 25. And those middle terms cancel out. So it's just the first term squared minus the second term squared. That idea gets used here to cancel out the two radicals in the denominator. So all you have to do is take that denominator with the two radicals, and all you have to do is change the plus and minus. This was root 5 minus root 2, so we're going to multiply by root 5 plus root 2. If you do it to the denominator, you have to do it to the numerator too. Now this looks terribly complicated, but don't worry about it. So look at the numerator. It's 6 times root 5 plus 6 times root 2. In fact, I'm not even going to do anything with the 6 yet. I'm just going to leave it outside. I'll say 6 times root 5 plus root 2. Our denominator, when you have those difference of squares, those conjugates, the shortcut was you square the first term, you always put minus, and you square the second term. So if I square the first term, the square root of 5 squared is just regular 5. Put a minus. Square the second term. The square root of 2 squared is just 2. That's it, dude. Now, look at that denominator. Five minus 2 is 3. And then we have the 6 and the 3 to simplify. 3 goes into 3 once. 3 goes into 6 2 times. So it's just 2 times root 5 plus root 2, which, if you wanted, you could distribute that and make it 2 root 5 plus 2 root 2. You're not going to have to do a lot of problems like that. I just wanted to show you that in case that pops up somewhere along your mathematical journey.